Well, happy day, ladies and gentlemen. I guess I don't know if it's morning or afternoon or night when you're watching this, but I was about to say good afternoon because it's afternoon when I'm making it. So we are going to start with 4A. We're going to start solving nonlinear systems of equations. So looking at this where it says nonlinear, hopefully that gives you a clue that they won't both be lines like we did back in chapter 3 where we solved systems of equations, but they were both lines. So here we're branching out of that into some will be a parabola and a line, and some will be two parabolas. So let's get started. And at first, let's talk about solutions. So what are solutions? Well, solutions to these systems are going to be ordered pairs where the graphs intersect. Oh, that was really poor handwriting. Where the graphs intersect. So order pairs where the graphs intersect. And when I mean the graphs, I mean like the pictures that we are graphing. So for example, if we have a parabola, the graph of the parabola is a U. It's not like this is a coordinate plane. That's not a graph. Well, anyway. When I say graphs here, I mean the U and then the line. So if I'm doing this, I've got a U and a line. So solutions are going to be where they intersect. So we can see they intersect here and here. So that is going to have two solutions. So unlike back when chapter 3, when we only had lines, we could only have one solution when they cross. Here with a U, we can cross it in two different places. So you can have two solutions, which is different. You can also only have one solution. So like back in chapter 3, where they only cross in one spot, or intersect, sorry, not cross, where they intersect in one spot, we can have one solution. And just like in chapter 3, sometimes they don't intersect anywhere, and we can have them just straight up missing each other, where we have zero solutions. Okay, so possibilities so far when we have a parabola and a line, we can have two, we can have one, or we can have zero. Now over here, when I have two parabolas, there's a little bit different stuff going on. So if I've got a parabola, so here's my U, my parabola. If I have another parabola like the same parabola, so see they are one on top of each other, they are intersecting every single place that they exist. So this has an infinite number of solutions. So if they are the same parabola, they have an infinite number of solutions. Then we can also have one solution, and there's a whole lot of different pictures for this. You can have a parabola with another one that kind of is next to it, and they only touch in one spot. You can have one that opens up and one that has a reflection over the x-axis, so they touch in just one spot. Or you can have one that has a vertical stretch, so it's tall and skinny, and one that is either normal or has a vertical compression, so it's wider, and where they only meet in one spot. So any of these that they only meet in one spot, they're going to have one solution. You can also have two solutions. So there's a bunch of options where they have two solutions. Why don't you go ahead and think in your brain, how would it look like if you had two solutions? What are some pictures? And if you can think of one, go ahead and draw it. Pause it and draw it. So there's a couple that I can think of. We could have a normal parabola, and then we could have one that goes upside down and through it. So we've got two places where they intersect. You could also, just like this one up here, kind of have one that's a little skinnier and one that's a little wider and kind of goes through it over here. crosses there in two spots, intersects there in two spots. And then there's also an option with two parabolas to have no solutions. So an option for no solution would be like one opening like such and another one below it with maybe a stretch or a compend and a shift down. Or you could have one up over here and the other one maybe has a shift right and a reflection over the x-axis. So it opens down and it's over there. So a whole lot of options. So you can have infinite, 1, 2, or no solutions when you have two parabolas. So how am I going to know if I've got parabolas or if I've got lines? Well, anytime you have a parabola, you are going to see something squared. And when you have a line, you're not going to have anything squared. So when you see that something is squared, that's a hint that that's going to be a parabola. And a line will not have a squared. So which one of these is the parabola and which one is the line? Hopefully you recognize that this top one up here is going to be the parabola. So y equals x squared plus 4 is the parabola. So when we are graphing a parabola, we need to look and see if it's in vertex form or if it's in standard form. And this one actually is kind of in both. So what we are going to do for this one is try to find the vertex. So the vertex is opposite of inside and outside stays the same to find the vertex. So since we don't have any parentheses, the vertex is going to be at 0. And then outside or after the squared is my y value, which is 4. So this has a shift up 4. And then, so to graph that, we are going to shift up 4. And then after we graph that vertex, we are going to go right 1, up 1, right 2, up 4, and right 3, up 9. And we're going to do that on both the right and the left. And then, so let's go ahead and do that. Here's my vertex. We're 1, up 1 on both the right and the left. Then remember, you always have to go to the vertex to count over 2, up 1, 2, 3, 4. Back to the vertex, left 2, up 4. And then it doesn't look like I'm going to be able to get up 9 on there. So we'll just draw that in. Remember to make a nice, smooth, continuous curve when you're doing a parabola. Okay, this one down here, this is a line because it just has an x. This is a line in slope-intercept form or standard form. Hopefully you know that it's in slope-intercept form because the y it's by itself. If it were in standard form, x and y would be on the same side and we would do cover-up method. However, this is in slope-intercept form, so we look in front of the x to find the slope. Our slope is 1. We always turn that into a fraction, so we put it over 1. And the y-intercept is the number that comes after the x, and we always, 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 always write that as an ordered pair. 0 is the x value every single time, and the y value is the number that comes after x. So 0, 6 is my y-intercept, and then my slope is rise over run, so I'm going to rise or go up 1, and then I'm running, going right 1. So over 1, up 1, a couple times, maybe down and left. Give me a good straight line. Hopefully you have a straight edge at home to use or wherever you're taking these notes. I didn't have a straight edge, so that's not a great line, but go with it. We'll pretend it's good. Okay, so that is what the graph looks like, but this says that we need to solve. Well, actually it doesn't. The instructions on your Math Excel will be to solve this. So we need to solve it graphically, which is cool, but we need to solve it algebraically. We have to solve it algebraically. So how we are going to do that is, since these are both equal to y, we are going to set the y equal to the y, or set what y equals to each other. So on this side, I have x squared plus 4. So this y is x squared plus 4. That's what that first y is. And the second y is x plus 6. So I'm going to set that equal to each other. So now we are going to move everything onto the same side. So I am going to move this x over, and I'm going to move the 6 over. We want to get it all on one side. So we have x squared minus x, and 4 minus 6 is negative 2. Okay, we have that because x squared and x are not like terms, so they just sit next to each other. And 4 minus 6 is what gave me the negative 2. Okay, now this equals 0, so now I need to solve this. So what I am noticing is that this x is squared. So that tells me that this is quadratic. It's a quadratic equation. So we actually know a lot of ways to solve this. We could solve by, the first way we know is we could do factoring. And remember though that factoring does not always work. Remember that factoring does not always work. The second way we could do it is by square root method. But again, that one does not always work. There's two more. Can you think of either one? There's two more. The next one that we learned was completing the square. And that one does always work. And the last one is quadratic formula. Sorry, my orange pen is running out. And that one also will always work. Okay, so you can kind of pick which one of these are you the best at and try it. And then if it works, cool. If it's one of these two, if it works, awesome. If not, try one of these two. Okay, or you could just, if you like one of these two, pick that and do it always. So I noticed that my A times C is going to work, so I'm going to solve this one by factoring. You can select a different method if you would like and see if you can come up with the same thing that I do. So how we are going to do this is A times C, so that gives me negative 2x squared. Making my list, I notice that this being negative, I'm going to have one positive and one negative. And it needs to add up to negative 1, so I know my bigger number is going to be negative. So if I make it negative 2x and 1x, does that give me negative 1? It sure does. So if I bring these down, x squared minus 2x plus 1x minus 2. And then we start to GCF this. These two have an x in common, and what's left is x minus 2. These two, I actually don't see anything that they have in common. So since they don't have anything in common, I'm just going to factor out a 1. And what remains is x minus 2. So then it doesn't really matter which one of these you put first. I'm going to put my x plus 1 first. And my x minus 2 second. And that still equals 0. So now I'm going to use the zero product property and set x plus 1 equal to 0 and x minus 2 equal to 0. To solve this for x, I'd subtract 1, so I get x equals negative 1. And to solve this for x, I would add 2, so x equals 2. So why are we doing this? Well, we're trying to figure out where the graph intersects. And yes, I know it looks like we can tell where it is, but it's kind of like a research paper. Like, this is where I think it's going to meet, but I always have to back it up with math. So you have to solve it algebraically, even though you're pretty sure you know what is going on here. Okay, so it looks like I've got, looking at my graph, I've got two solutions. So this solution, the x is negative 1. On this solution, the x is 2. But I need to find ordered pairs. Well, how am I going to find those ordered pairs? Well, what we are going to do once we have the x's is we are going to sub the x values back into one of the original equations to find y. Okay, so we're going to sub them back into one of the original equations, and it doesn't matter which one. So since this one, just x plus 6, looks a little easier, that's what I'm going to do. So y equals x plus 6, so y equals negative 1 plus 6. Well, negative 1 plus 6 is 5. So the y value here is 5. On this one, it's going to be y equals 2 plus 6, and 2 plus 6 is 8, so the y value here is 8. But my ordered pairs, my answers here, negative 1, 5, and 2, 8. That's what I need to have. So let's double check, did my graph support that? Did my math support my graph? So negative 1, 5, yeah, and 2, 8. So did my math support where my graph is saying that those intersect? Yes, it did. So we've got our graph backed up by our algebra, and so we can safely say that these two are the answers. Okay, flip it over. Let's try a couple more. Okay, so on this next one, we've got two parabolas, so we know we can either have infinite solutions, one solution, two solutions, or no solutions. So what we are going to do here is first graph this one. This looks like it's in, well, it could be in standard form or vertex form. It looks like I have a compression of 1/2, a vertical compression of 1/2. And it also looks like I have a shift up 2. So that tells me my vertex is going to be at 0, 2. And I would go over 1, up 1, but to compress that by 1/5, remember your ups get multiplied by 1/2. So up 1 times 1/2, which will actually be 1/2. Over 2, up 4, but we have to multiply it by 1/2, which gives us 2. And over 3, up 9, compressed by 1/2, which gives us 4.5. So 0, 2 is up 2. Then we go over 1, up 1/2. Go back to the vertex, remember always. Over 2, up 2. And over 3, up 4.5. Let me draw that in, nice smooth curve. And my next one looks like it's got a shift down 6. So its vertex is at 0, negative 6. And here we go. And it does not have a compression or a stretch at all. So we are going to go our normal over 1, up 1, over 2, up 4, and over 3, up 9. Okay, now this one, oops. Okay. I think this is probably bad. Probably should go out a little bit more, but we'll figure out where it goes. And then we'll see how bad my graph is, because it doesn't look good. Hopefully yours is better than that. So again, we are going to, since these are both y equals, we're going to set our y equal to our y. So my first one is 1/2 x squared plus 2. So we're not actually setting the y equal to the y. We're setting what the y equals. equal to what the other y equals. Okay. And I just don't want to deal with fractions. Does anybody want to deal with fractions? So let's get rid of those fractions. So the way we get rid of fractions is we multiply by the denominator. So I'm going to multiply everything here by 2. So every single thing I'm going to multiply by 2. So 1/2 by times 2 is going to be x squared. 2 times 2 is going to be 4. And then on this side, I'm going to have 2x squared minus 12. Okay, now I want to move my smaller of the x squareds to make it equal, to make it on the same side. So since this one is smaller, I'm going to move it over. This is an x squared, so I'll subtract it from its like term. And -4 is just a number, so I'll subtract it from its like term. So what happens here is this side cancels. 2x squared minus x squared is just going to be x squared. -4 or -12 minus 4 is -16. So actually, I can see 2 easy ways to solve this. So I'm going to show them both to you. 2 easy ways to solve this. The first one is square root method. Okay, and I recognize that this was going to be square root method because x squared is a perfect square and so is 16. So if I have the square root method, the thing that I'm trying to isolate is the variable that is squared. So I'm going to add 16 to both sides. So I have 16 equals x squared, and then I take the square root of both sides. And remember, anytime you put in the square root, it has to be plus minus. So plus minus, then the square root of 16 is 4. And as soon as I change that from 16 to 4, it doesn't have the square root sign anymore. Okay, so notice I have plus minus 4. Okay, the other way that I can see that it would be pretty simple is to factor. Okay, so to factor this, x squared is a perfect square, 16 is a perfect square, and with them being subtraction, this is a difference of squares. You can find that back in your 4-5B notes if you don't remember how to factor this. But it factors as x plus and x minus, because x times x gives me x squared. And what times itself gives me 16? Well, 4 and -4. Or sorry, gives me -16. So then when I solve these, set them both equal to 0, I get -4 and 4. So same thing, -4 and 4. Now I have my x's, but I don't have y's. Remember, to give an answer, I need an x. One of my x's is 4, and the other x is -4. And to get the y's, what do we need to do? Hopefully you remember that we need to sub them back in. So back into one of these original ones. I'm going to pick the bottom one just because it looks a lot easier. So it's going to be y equals x squared minus 6 for both of these. So let's put our 4's in there and -4. Okay, so y equals 4 times 4 is 16. 16 minus 6 is 10. And over here, -4 times -4 is also positive 16. Minus 6 is 10. So I knew I messed up on my graph because they should have intersected here and here. And actually, oops, you can't see that. Actually, neither one of my graphs went through there. So I should probably go back and make these better graphs, but that would require a bunch of whiteout. So hopefully your graphs are better, and if you're using a pencil, go ahead and erase those and make them better. Last but not least, okay, so this top one is kind of difficult, so we're just going to take a pause on that one, and we are going to do this one real quick. This bottom one is just the parent form, or the parent, the parent of x of quadratics. So it's got a vertex at 0, 0, and it does the normal over 1, up 1, over 2, up 4, over 3, up 9. So let's graph it real quick. Okay. This other one, I wanted to take a pause on it because it is actually in standard form. So if you go back, I believe it's in 4.2 that talks about how to graph standard form. But in standard form, in order to find the vertex, to find the x value, you do opposite b divided by 2a. So we need to do opposite b divided by 2a. So hopefully you know by now which one of these is b. B is the second one. B is negative 10, so I'm going to do the opposite of negative 10, which gives me positive 10, divided by 2 times a. A is 1 because it's in front of the x squared. So 10 divided by 2 times 1. 2 times 1 is 2. 10 divided by 2 gives us 5. So in my vertex, I'm going to have 5 something. Well, how do I find that something? I take this equation and I plug 5 in for the x's because I know x is 5. So it's going to be 5 squared minus 10 times 5 plus 20. So I'm going to have 25 minus 50 plus 20, which would give me negative 25 plus 20, so negative 5. So my vertex is at 5, negative 5. So that means I will go right 5 and down 5 because remember when you graph an ordered pair, you go right and left, then up and down. Okay, so then we normally go right 1, up 1, right 2, up 4, and right 3, up 9. Let's see if we have a stretch or compression that messes with that. We don't, so this is going to go right 1, up 1, same on the left, go back to the vertex, right 2, up 4, right and left, go back to the vertex, right 3, up 9. Uh-oh, I lost count. 9. Okay, and right 3, up 9. Oh, okay, so it looks like these are going to intersect at one place. Ooh, I missed that point. And it looks like that place is at 2, 4. But do we just get to go, yeah, it's at 2, 4, yay life? No, we have to back it up. You always, always, always have to back it up with algebra. So again, we are going to set our equations equal. Make sure they're set equal to y, and if they're not, move stuff around so that they are. So my first one is the stuff that y equals. So on the other side of the equation from the y is going to be equal to the stuff on this other side of the equal sign from y. So x squared. So again, we need to get everything on the same side. So set it equal to 0. Looks like the way fastest way to do that is just to subtract this x squared. So then it looks like, oh, those cancel. So I'm going to have negative 10x plus 20 equals 0. Oh, so this actually ended up being pretty nice. So notice, is there an x squared any longer? There's not. So when the x squared is gone, this is linear, which means it's only got one variable left. So what we need to do is we set the variables equal to the numbers. So we're going to get the letters on one side and any numbers on the other side. So to start that, I'm going to subtract 20. So then I have negative 10x equals negative 20. And then I will divide both sides by negative 10. And so x equals negative 20 divided by negative 10, which is 2. So I know that in my ordered pair, I'm going to have an x value of 2. Now I need to find my y value. How do we do that? Hopefully you know that to do the y value, you sub it back into one of the originals. So I'm going to pick the second one because it's got a lot less going on. So y equals my x squared, or 2 squared, which happens to be 4. So did I back up my graph with math? Yes, I did. So make sure, couple things, that when you're graphing, that they always are y equals to begin with. And if they're not, that you make the y by itself before you start. Then when you're solving, set the stuff that y equals equal to the other stuff that y equals. Get everything on one side. If it's still an x squared, solve by factoring, completing the square root method, or quadratic formula. If it's not squared, you solve by it being linear, getting all your variables on one side and all your numbers on the other. Good luck on your assignment, and let us know if you have any questions.